I'd like to now continue on in my conversation about ArcGIS. As I said before, it's an open platform, but perhaps you didn't realize that it's actually two systems. It's both one system, but it's also two systems. It's both a comprehensive GIS system, system of records, heavy analytics, software tools, the so-called ArcGIS Enterprise software and Pro, but at the same time, it's also a lightweight mapping and location platform. And the combination of these two is really interesting. As you saw at USDA, they were not only doing heavy lifting, managing their systems of record, but also making it available through devices for everyone using ArcGIS Online and cloud-based services. You get this distinction? This is a shift for Esri in explaining its platform. We've always talked about it as one integrated system. But more recently, we've been talking about it as two, because it is two. It supports the GIS professional on one hand, but it also supports the rest of the entire organization on the other hand. So I'd like to go through these two categories so that you understand them completely. ArcGIS Online, the cloud system, is huge. It has over 5 million users. It has over 15 million data sets that have been shared. It gets so many hits every day. We make about 1 billion maps a day. Okay, it isn't Google, but it's a simple way, interactive way, immersive way to get involved in geographic data and share it. ArcGIS Online includes thousands of layers, many of them government layers, like all of the FGDC layers and services as services, imagery, soils, demographics, that are made available as a platform for use by not only other federal workers, but workers in the private sector, at the state level, etc. This is, from our estimates, the largest collection of geospatial information. We might call it a living atlas, because, by the way, through your good work, it's being shared and used by many users dynamically. It has the following characteristics. First, you can make maps with it. But these maps are not just maps. They're smart maps. They're bringing in some of the aspects of AI into building maps dynamically so that a mere mortal can build beautiful cartographic displays, both 2D and 3D. And here we're improving tools like clustering, increased visual performance with things like WebGL, and making more dynamic analytics. It has dozens of location analytic tools. These are not unfamiliar to the GIS professional. Map overlay, spatial analysis, aggregation. Tools, however, that are very easy for a layperson to be able to leverage dynamically. It also has associated with it the exploratory data analysis and visualization, insights. This is a sort of drag and drop BI, business intelligence platform but it's richer because it has spatial dimensioning with it. It's a self-service analytic tool that, well, that's pretty exciting. Any of you using it here, by the way? Somebody raise your hand, please. My God. Now, this is powerful because it's only about 6 weeks that it's been released inside of ArcGIS Online. We've been working this technology for the last several years. It has maps and charts and graphs, but one of the elements that we've just added, and it'll be shown in a few minutes, is something called a link analysis, which links different things in space and, of course, time. Best to see it actually in action, so we'll wait for a few minutes before we see it. In this mapping, simple mapping and location platform is also all of the field apps for data collection, like Survey 123 or Collector. Also apps that allow people to be managed in the field, workforce and navigation apps and sketching apps. In the very same ArcGIS Online platform, there's a new technology called Hub, ArcGIS Hub. About 6 weeks ago, we released it for the first time. This one is designed to involve communities. Maps are engaging, as I said earlier. This is about providing citizens not just open data, but open information in the form of mapped expressions. And it's also designed to gather information from citizens and give leadership back what people think. I mean, the best way to think about this is a community meeting. In my little community, we have lots of little community meetings about parks, about trees, about trash, about all the different subjects that citizens care about locally. In this case, we're trying to develop a social media framework for doing the same thing, bringing maps into communities as a way to language issues about policies. And it's organized through what we call initiatives. So initiatives about highway deaths, or initiatives about homelessness, or initiatives about environmental issues expressed through maps that are two-way interactive. So this is a big step for us. And while it's not relevant as much to national government as it is to local government, I see a day when we'll use maps at a societal level as a way to really create a stronger and richer and open democracy. Also in this platform are a whole series of apps, and we saw some of them shown here by USDA. Apps for the office, like Maps for Office. Earth, a kind of representation like a Google Earth tool. Planning tools, design tools, and also apps for the community. Field collection apps, open data apps, crowdsourcing apps, crowd reporting apps. They just come with this mapping platform. But most apps are apps that people want to build themselves. So with this open platform are web app builder tools, so I can build my own app, not even as a programmer, but just use widgets, drag them around, and create an app in a matter of minutes. Last year, over 500,000 new apps were created in ArcGIS Online alone. And for those who are interested in device apps, there's also a technology that allows widgets to be able to be dragged and dropped around in building creative user experiences in devices. And the remarkable thing here is I can build it in an Android and then convert it automatically to an iPhone, or taking advantage of the native devices. Finally, this environment, I'm talking here about the open web, simple mapping environment, has very powerful tools for developers. For example, in data visualization, I can bring my own data and see it come alive with smart mapping and so on. But also improvements here, for those of you who are technical, are the integration with WebGL. And look at the performance of this map in the lower left. This is all of the buildings in New York City visualized in a browser in a matter of seconds. Well, I always get impressed by that. I suppose you're not impressed by it, I don't care. I'm very excited about it. And then lots of tools, 3D tools, visualization tools. All of these are built with JavaScript API. What this means is I don't have to have any software on my device or in my browser. I don't have to have any plugins. I can actually make cool apps and access services-based data sets, build them quickly, and leverage all the modern programming tools. These are some examples. I was in Switzerland with my colleague Scott Morehouse a couple weeks ago, and our dev center there built an app using this that runs on devices. You're going to see this a little bit later, but it's just like, wow, somebody sent me a link. I opened the link, and I'm into a 3D globe flying through Switzerland's trail. Okay, again, my words are not going to do it for you. You've got to really see it, so wait for a few minutes. I've talked about the high-level points of what we're doing with the mapping platform. I now want to shift gears to talk about ArcGIS Enterprise. This is the server environment, the software environment, Pro, and so on, that is the meat and potatoes of so much of your work. This system supports GIS in your own infrastructure. It can also be put in the clouds, so it could be your own cloud infrastructure. And its patterns include desktop with Pro, the Enterprise complemented by ArcGIS Online, And finally, this new pattern that's emerging among you and among our users in state and local governments, distributed services serving each other, a system of systems. And that's where I think this is going to go. Open system of systems, lots of different players, lots of different parts. I'll talk now at a deeper level about some of the specific things that we've been engineering and have gone out in the last release a couple weeks ago. One is we've introduced a new utility network. This is for the billions of features that are IoT related, like smart meters, like your little home smart meter stuff. This is a new data model to be able to deal with smart grid. Second, we've been working closely with our colleagues at Autodesk Corporation, a kind of transformation in our relationship there, so that we can integrate in complete BIM models into the ArcGIS environment. And moreover, the GIS tools can be integrated completely within engineering tools that Autodesk makes. BIM, CAD, integration with GIS. We've also improved editing, 3D editing, being able to do stereo and feature extraction right in the standard technology, and then faster and faster and more accurate geocoding globally. In the field of mapping and cartography, in ArcGIS Pro particularly, we've made advances in symbology and annotation, smarter tools, tools that do automated generalization, and implemented the complete environment for vector tiles, being able to create and cache in a vector environment for high performance data. You'll see lots of that later this morning. And more improvements in smart mapping, and more improvements in production charting, and more improvements in our educational material to teach you about great cartography. Now, one of our big initiatives this year is to make everybody better at making maps. So sometimes I look at maps by our users, and some are just fantastic, and others are really accurate, but they don't really tell a story. So we're placing a lot of emphasis in educational materials, videos, MOOCs, online materials, to be able to teach all of our users the art of cartography, complemented by more machine-driven tools. Finally, we have been asked by you to make our tools totally integrated with the Adobe Creative Cloud for doing map finishing, and we have accomplished that this year as well. Another major frontier in GIS is making GIS totally 3D. And this starts by being able to read any kind of 3D data. Not just the CAD, BIM 3D data, but these massive LiDAR data sets of billions and billions of LiDAR points that are collected by some of our colleagues in different business partners. And oblique imagery and photogrammetry and so on. But it's not just reading the data that matters, it's adding tools that allow high performance visualization and analytics in various apps. Our ArcGIS Earth is now in its 7th release, and I mean, it is getting very, very strong and very rich because it accesses distributed data sets and puts them in these globe environments for visualization. And more on the edge are the ability to do stereo display, augmented reality, and new forms of abstraction. You probably can't see it, but that little gray thing over in the lower left, I want you to watch it over the next year. It's a new way to look at 3D data, but then represent it as like a sketch. It's quite extraordinary. Well, maybe you don't care about it. I don't care. I love that thing because I can look at 3D data and look at it as if it was manually drawn. My background is landscape architecture, and all this machine-looking graphics, I want to make it look like it's more human. So we're on an adventure to be able to do that. Hey, thanks. I've got one other landscape architect in the field here that loves me. Thank you. In the field of imagery, ArcGIS is now a complete image management system. It has a new advanced image workstation brought to us by a new extension released in January. It reads any kind of sensor. Okay, maybe that's an exaggeration. Almost any sensor, all the popular ones. And it also has a server that allows us to serve out imagery using a concept of dynamic processing. And if you look on the right, we can now do massive orthophoto generation, both at the desktop and in the server. And this dynamic processing means I bring in new imagery, and it can create new information products dynamically as the new imagery is coming in. This is transforming all kinds of organizations because I don't have to store all the data, process the data, and then be able to use it. The data stream comes in, and I can be using it in my application almost simultaneously. In the field of spatial analytics, this is looking at relationships and patterns. There are over 1,000 of these tools. These are some of the new ones, and the new ones are in particularly space-time, spatial statistical tools that look at exploiting information over long periods of time. Also, our work in integrating science has been very powerful and rewarding, being able to have total interoperability between R, the language that most scientists now commonly use in data science, and also the integration of machine learning environments using the Python API. I'll come back to that in a few minutes. Also improved performance and lots of other things you'll get in the workshops later. In that field of machine learning and spatial data science, I mean, we read about this in the newspaper. It's a hot topic in the Silicon Valley, right? Correct? Yes, okay, good. Just want to make sure you were listening. It turns out that many of the machine learning tools that are popularizing today have been inside of ArcGIS for many years. Things like EBK, or exploratory, empirical-based kriging, or things like random trees or clustering. These are fundamental geospatial tools. So we're continuing our work there, but also integrating with many of the machine learning libraries, things like TensorFlow or IBM's Watson, so that these two different environments can talk back and forth with each other to make a smarter world. One of the intentions of our work in AI and machine learning is not to reach the science world, although certainly there'll be users of it. It's to build practical tools integrating these new technology trends right into the tools that you build and use every day. That's a major focus for us. It's not sort of the exotic stuff. And there'll be lots of exotics and lots of work done with exotics, but you get my meaning about this notion of how can we make it practical. Tools like these, applications like these, show it very clearly. Backing up machine learning are two different extensions that we have built. One for vector data, feature data, with a geoanalytics server that can handle massive amounts of big data collections. And second, raster data, or imagery data, that can handle like 10,000 images, being able to do batch processing. These environments built on Elastic and dealing with very large volumes of data are becoming commonplace because of this continuing persistent measurement. On the left, you see the ability to take 10 million observation points of outages in Houston. And you can look at the space-time cube of hotspots. The red areas are getting hotter, more outages. The blue areas are getting colder. And the vertical is time. So over a few minutes to hours, based on the size of data, I can derive new understanding from my information. On the right side is the same kind of thing happening with raster data. And way on the right, you can see a raster analysis being performed on a 10-meter grid of elevation for the entire country. Here in a couple of hours, running with 230 billion raster cells, we were able to derive detailed hydrologic modeling criteria. This is a key element. And another key element is real-time data, because as real-time measurements are coming on, we need to not only be able to drop them into these big data environments like the geoanalytics server, but also serve them up dynamically onto dashboards like some of the dashboards that you saw just represented in the machine learning examples. Here, the improvements that we've made with real-time sensor networks are scalability. Last year when we were here, we could deal with 2,000 or 3,000 observations a second. This has now been scaled up to hundreds of thousands of observations a second. Being able to dump into the little lower right-hand corner data cube so I can do subsequent batch analysis, but also right into real-time situation awareness displays. You saw examples, a couple of examples of the open scripting environment, the Python API that now allows data scientists to be able to reach into the innards of both ArcGIS Enterprise Server and also into ArcGIS Online. Now, for many of you, this is just some technical mumbo-jumbo. Not for me. Not for me. This allows, at the command line level, for me to be able to pull functions that are spatial operators with very large data from these big environments and script or sequence a series of batch processes. This can automate much of the back office work that goes on. But more importantly, this Python environment is what data scientists use. They mix it with notebooks or Jupyter notebooks, so that if I'm a data scientist using a Jupyter notebook using Python, I can just connect with a massive data set or a bunch of massive data sets over a network. So for me, this is going to empower the GIS professional to be able to scale up and automate and make more open and available their content. ArcGIS is fundamentally, by design, open and interoperable. We do this in three ways. We support this in three ways. One is through standards and formats. Being able to work closely with OGC has been a privilege, and being involved in that community is very important for us, as well as ISO and WWW. And those standards keep evolving along. But sometimes standards are not the high performance that we want when we're connecting one technology with another. For example, the Autodesk environment. Yes, we can ETL data from a BIM model into a GIS and do something with it. Fundamentally do two different semantic and technical models. But more important is being able to directly buy this COTS product and this COTS product, and they just work together. This is tough from an engineering perspective, but you'll notice in the blue triangle or polygon of some sort, a lot of different direct integration points that make interoperability easier. And finally, our third strategy is to support open software. This means open APIs, open data, and more importantly, an enterprise integrated, extendable architecture, so I can extend the platform or embed the platform inside of other applications. Finally, we share hundreds and hundreds of open source projects in GitHub so that other users can and others can use our basic tools in an open source environment. These three prongs on our strategy are really important. And I just say they work. They just work. And the evidence that they work is the tens of thousands of heterogeneous environments where our software is plugged in and working at high performance with other systems. I'll conclude my talk this morning by talking about the actual components of what ArcGIS is about. I'll do this briefly. First component is ArcGIS Desktop or Pro. And for those of you interested, ArcGIS Desktop has really two applications. One of them is ArcMap, originally developed over 15 years ago. And we will continue evolving that platform with different releases through the future, long into the future. But replacing that product in a 64-bit environment with much higher performance and lots of new functionality is ArcGIS Pro. We'll see some demos of it after the break. And that environment is closely integrated in with the whole web services environment. And you can glance through some of the new improvements that we made a few weeks ago with the 2.1 release. And we'll make more this summer, real-time streaming, the Autodesk integration. For some of you, it's important to support FMV or full motion video, and then more predictive analytics. And you can see the kernels of some of that happening with the machine learning tools. Pro has many extensions. Some of you are familiar with them, things like 3D Analyst or Spatial Analyst, but a few might not be familiar to you. One of them is Image Analyst. Image Analyst is a standard extension now released in January that turns Pro into a full professional image processing workstation. Everything that you want to do with respect to imagery can be done. Well, nearly everything. I wouldn't say that's everything. But certainly the rank and file image analytics in the same workstation environment. And then there are a few over on the right that perhaps you're not familiar with. Workflow Manager, which is about complex workflow management. Data Reviewer for QA, QC, and finally data interoperability, which is a tool from Safe Software that is embedded inside of an application that just plugs into Pro. The second leg of the stool of ArcGIS is ArcGIS Online. I spent a lot of time on that. I won't go through it again. It's a mapping and location platform for people that don't really have GIS training, but also we find millions of users are using it that are GIS people. So how do you explain that? Well, it's totally integrated with Pro and totally integrated with our server technology. So you can link and integrate it as one seamless system, but you can also use it independently. And you can glance through here some of the new innovations that have happened this winter. My favorite is being able to do some of this advanced clustering work that you saw demonstrated a few minutes ago. And what's coming here is, again, increased performance in visualization, more intelligent search, which is underpinned by strong metadata support, and then organization-to-organization collaboration. This means one organization with an online environment can collaborate with another organization sharing metadata and services more effectively. The third leg of this stool is ArcGIS Enterprise. This is the back office environment. It's massively scalable and modular in its deployment, so I can put it on many machines. And I think Tony, don't you have like 4,000 machines running the weather service now, or cores? It's very scalable. We have NOAA, but we have UPS, which has 5,000 cores running in massive clusters. What we've been doing here is improving some of the experience for setting it up using a new enterprise builder, which is an automated script to be able to help you stand it up and support it more effectively, and integrating with Chef. And you'll notice on the bottom right, total integration now, so I can, in a couple minutes, stand up a server in AWS or in the Microsoft environment. One element that many of you have asked for over the years is the ability to have one portal and enterprise system talk with another portal, sharing metadata content across the network. So this is a beautiful design, so I can have many different departments or agencies or teams working independently, updating their own databases, but the access to the data, the metadata, can be shared from portal to portal or in a hierarchy. So I might imagine here a portal of portals. This is the big idea. Or even take the content in a portal and replicate it on the outside environment of ArcGIS Online. This is actually the foundation for the hub, where not only my metadata can be shared, but look at in the upper left, it says sharing maps, scenes, layers, and related content. And related content. This means I can replicate not massive data sets, but let's say little updates that are happening in one agency, like on a map, can be sent to another agency where the data is replicated dynamically, periodically. This is going to transform this idea of systems or the SDI work. ArcGIS Enterprise, this massive distributed modular server, also has these extensions, and I think I've covered them in part. The image server for very large raster and image processing, the geoanalytics server for very large collections of massive observational data, the geo-event server, which is the real-time IoT thing. But then there's two new ones. Here, a utility network management environment, probably not so interesting to most of you, but very interesting to our utility customers. And finally, the ArcGIS Monitor. The ArcGIS Monitor is an extension which, for high-performance environments where we need replication and lots of things going on at the same time, it gives us a monitor of the status of what's going. Beyond ArcGIS, Esri supports a series of focused applications, and these are very much for unique domains in geodesign, in location intelligence, like massive geocoding or community analytics, and then some specific things for transportation and pipelines, for airports, and of course the new GIS hub. Finally, ArcGIS supports a series of other products. They're called solution products. These are all free products. They layer on top of the core platform. We have a team of about 60 or 70 people that build these products. They open source the products, and they're available for download by both you, our users, and also our partners. And they cut right across different industries. The ones particularly in heavy federal use are the military security ones and emergency management. But those of you who are in state and local government here will be familiar with many of the parcel data management tools and pipeline data management tools and the like. I've talked about ArcGIS in various flavors. I've talked about it as an enterprise GIS. You remember? Okay, this is not a lesson, right? I'll take a test later. Enterprise system. I've also talked about it in terms of being a simple mapping platform. And these can live independently or in an integrated way. Simple mapping is not just for people that don't know GIS, it's also useful for professionals. So the simple mapping stuff is also part of enterprise. But the third part, which I haven't talked as much about, is that it's also a developer platform. Last week we had 2,500 developers travel from all over the world to Palm Springs, near our headquarters, and they're developers. So the hood of ArcGIS is also open for developers, and some of the advancements that we've made here are in simple JavaScript APIs that just are amazing. And runtime, the ability to embed parts of our tools into apps. Those of you who are system integrators will think about this in terms of ArcObjects, our previous generation of embeddable tools. And then the Python thing, and then customizing Pro. So this is an important part of our culture. Esri's culture is to be engineering focused, not just for end users, but also empowering our partners and developers in your organization with these tools.